Let's take a look at page 20. On this page, there are 3 pictures at the bottom, or 6 figures at the bottom, and I am telling you that they are similar. They are in 3 sets of similar pairs. To review, that means that the sides are proportional, they're the same shape, and your corresponding angles are congruent. Now, we can use this information to help us in figuring out a missing side. Some of them will be a little bit easier. Let's take a look at the first 2 rectangles, rectangle ABCD and rectangle PQRS. If we look at this rectangle, we can notice that for the short side compared to the long side, we're comparing 8 over x to 6 over 12. When we look at this, we are able to cross multiply, but we can also notice that we would say 6 times 2. So we would want to do the same thing to 8 and do 8 times 2. And we would find out that x is going to equal 16 units. Now we could cross multiply this and we should still get the same answer, but there are going to come times where you're able to just put it into the 2 ratios and solve it as quick as that. But notice that I gave a set of units on the side just to help me make sure that we aligned the numbers correctly. There are a lot of students that would have lined up the 8 over x and the 12 over 6, not thinking about I have to have the short sides on the same side of the ratio bar and I have to have the long sides on the same side. Now let's take a look at the second pair of rectangles where the relationship is not as obvious. So we're comparing 2 rectangles. So once again, I'm going to compare a short side to long side. You can call them something else. I just call them short and long so that way it makes sense in my head and I don't end up reversing where the numbers need to go. So on the first rectangle, the short side is 5 and the long side is 8. On the second rectangle, the short side is 3 and the long side, we don't know. Now we use our knowledge of proportions. 5 times y equals 8 times 3. We can't do what we did on the first one where we saw the relationship because we don't know at the top of our head how to get from 5 to 8 or 5 to 3 or 3 to 5. So therefore, we have to cross multiply. So 5 times y is 5y. 8 times 3 is 24. And then we're going to divide 24 divided by 5. And that's how we get that y is going to be 4.8 units. When they do not tell you meters or centimeters or inches or miles, kilometers, any actual units, then what you end up doing is just filling in the word units. For the third one, the 2 triangles, we're going to compare, I'm going to call it the side to the base. It's not the height because the height's always going to be up and down, so I'm going to compare the side to the base. On the larger triangle, the first one, we have the variable q, the base is 6. On the smaller triangle, the side is 5 and the base is 4. You can call them whatever you want. Those are just the terms that I chose to use. So we're going to cross multiply because we don't know off the top of our head the relationship between 5 and 4, 6 and 4. So we have to go ahead and cross multiply. 4 times q and 6 times 5. If you are still needing to circle to see what you're multiplying, go ahead and circle in case if you're needing to see it. If you don't need to do that, you do not have to circle. 4 times q is 4q. 6 times 5 is 30. Q is going to be 30 divided by 4. So Q is equal to 7.5 units. So you can see why knowing similar figures or knowing how to tell if they're similar can be beneficial, and we've used that information to calculate a missing side. Now we're going to take this information and we're going to apply it to word problems. The first thing I want y'all to note is that in word problems, a drawing can be helpful in setting up the proportion. The reason this is called indirect measurement is because we're determining the length or distance of something without measuring it directly. I'm not going out and measuring how tall is the flagpole or how long is the shadow with a ruler or a measuring tape. I'm going to use data and information that I know and relationships that I know about to apply it to something usually a lot larger or a lot smaller. The drawings are going to be thought of as a graphic organizer to help you set the proportion up. And we use that to solve the word problem. So you do not have to create a masterpiece. The picture just needs to be legible enough for you to understand how to set up the proportion. I promise you'll see in a minute that my drawings are not masterpieces, and I'm just going to ask that you don't laugh too much when you see them. So the things I want you to keep in mind for this are that shadows are on the ground, and we show this by putting the number along the bottom. And then heights should go on the side, because when you measure the height of something, you measure vertically. At no point is the height slanted. All right, so to start us off, we have a tree. So we're going to draw a beautiful tree. Okay, a tree stands 12 feet tall. And it casts a shadow 8 feet long. There's my shadow. You don't have to get super creative with what the shadow looks like. And at the same time, a person. If you want to make it a girl, feel free to add a hair bow. At the same time, a person casts a shadow that is 3 feet long. To the nearest tenth of a foot, how tall is the person? So let me read this again just so that you can see how it aligns with the picture. A tree stands 12 feet tall and casts a shadow 8 feet long. At the same time, a person casts a shadow that is 3 feet long. To the nearest tenth of a foot, how tall is the person? So we took that information, and now most people would set up this proportion 12 over 8 and 3 over x, because all you're going to see is feet, feet, feet. So you have to pay attention to units like tall and long, or you have to think about it in terms of you're dealing with tall and shadow. Either one of those to help you align things. So in this case, I'm going to compare tall to long. If you want to call it shadow, that's fine. But once again, we're giving us some words to help us organize our thoughts. When we look at the first proportion, or the first ratio, the tree, there was 12 feet tall and 8 feet long. Super easy to see once we put it into the picture instead of just looking at the words. And we look at the second one, that's going to be h over 3 feet. So now all we have to do is cross multiply, because we don't know any relationships between 12 and 8 or 8 and 3. 8 times h and 12 times 3. So 8h is going to equal 36. And to find h, we have to say 36 divided by 8. We were asked to round to the nearest tenth. We find out that h is going to be 4.5 feet. So this pretty much indirect measurement takes into account everything we've done with similar figures. Setting up drawings that look similar, setting up the proportion, and then solving the proportion. For the second one, Laura is 5 feet tall. So here she is, since it's a girl. And she casts a shadow that is 3.2 feet long. Oh, I forgot her height. 3.2. Okay, she's standing next to a flagpole. Is that my flag? And she's standing next to a flagpole that is 23 feet tall. To the nearest tenth of the foot, how long is the shadow? How long is the flagpole's shadow? So I'll use F. So again, if we take a look at our units, we're talking about tall and long again. So when we write our proportion, we're comparing tall to the shadow's length. So we have Laura, who's 3.2 feet tall, with a shadow that's, with the shadow that is, Laura's 5.5 feet tall, and a shadow that is 3.2 feet long. Sorry about that, guys. And the flagpole is 23 feet tall, and we want to know how long is its shadow. So we go about solving our proportion. 5.5 times F is going to equal 3.2 times 23. So we get 5.5F is equal to 73.6. So to calculate F, we're going to say 73.6 divided by 5.5. And we get that F is equal to about 13.4 feet. We knew we had to round to the nearest tenth because that's what the problem said to do. On to the third one. A Civil War monument in Charlestown, Massachusetts is 221 feet tall. All right, my monuments. It's beautiful, I know. And it's 221 feet tall. Make sure to pay attention to the numbers this time. Cast a shadow 189 feet long. At the same time, a nearby tree cast a shadow 29 feet long. To the nearest tenth of a foot, how tall is the tree? So when we look at our units, we're talking about tall and long again. In word problems with proportions and indirect measurement, those are two of the most common words you will come across. So we're comparing tall to long. So the monument's 221 feet tall over 189 feet long shadow. And the tree, we don't know the height, but we know that the shadow is 29 feet long. So we solve our proportion. 189 times T and 221 times 29, giving us 189T is equal to 6,409. To find T, we're going to divide 6,409 divided by 189. And we find out that the tree is about 33.9 feet. In every answer, I included units. And in every answer, I had to round to the nearest tenth because that's what I was told to do.